Hello all, myself Professor A.J. Murray, working as an assistant professor in the Department of Engineering Sciences in All India Physiology Development Society's Institute of Information Technology, Pune. My today's topic is Helix Curve. In Helix Curve, we are going to see what is the meaning of helix, then helix on cylinder, helix on cone, and various applications of this helix. What is helix? Helix is the curve. It is, I can say, it is curve generated by uh, curve generated by point which moves around the surface of a right circular cylinder or cone. Uh, at the same time, it advances in axial direction at the speed bearing a constant ratio to the speed of rotation. So there are two types of helix curve. So one is helix on cylinder and one is helix on cone. So if you see this picture, so it is the curve generated on a cylinder. You can see the orange color in the picture. This is the uh, cylinder, and in this another picture also one cylindrical uh, part is shown, and the in right left hand side the yellow color wire shows the wire is wounding around the cylinder of the surface, and similarly on the right side blue line indicates the one thread is wounding around the part. So this is indicating the curve which is generated around the cylindrical surface or cylindrical bar or cylindrical part moving axial in direction in axis with respect to the axis with the same speed and same ratio. So it is the curve, I can say helix on cylinder. It is the curve generated by a point on which moves around the surface of a right circular cylinder, at the same time advances in the axial direction at a speed which bears constant ratio to the speed or rotation. It should be a constant ratio to the speed of rotation in the axial direction, so that it will be moving around the axis of that cylinder. So that is the right circular cylinder basics. So if you move ahead, how this cylinder, helix on cylinder can be drawn, we can take one example. So this is example, draw a helix on one convolution means one rotation. So upon a cylinder given 80 pitch means the distance between two consecutive teeth or two consecutive uh, heads or two consecutive waves, and 50 is the diameter of the cylinder. So you might have learned the front view and top view concept of the cylinder. If you see from the front side, the cylinder is look like you know the rectangle, and from the top, if you see that the right circular cylinder is a circle. The axial advance during the one complete revolution is called a pitch of that particular helix. Axial one complete revolution, that is 360-degree revolution. So the basic thing is given, diameter of the circle 50 mm, and the pitch or the axis, that is height of the cylinder, is given for the one rotation or one complete revolution, that is 80 mm. So first of all, we have to see what we can draw. Draw the projection of the cylinder. So projection of the cylinder means we have to consider always that cylinder is resting on the horizontal plane and its axis is perpendicular to the HP and parallel to the VP. Then, so according to this projection or according to this position resting on the HP, we will get rectangle as a front view and circle as a top view. So in the top view, first we'll draw a circle of 50 mm diameter. Divide this circle uh, into the eight parts. So you can see the I have divided the circle into the 8 equal parts by maybe by arc method, or maybe by you can draw by using the arc of 45 degree angle concept. Then the axis equal to 80 mm, that is the pitch of one complete revolution is given. So divide that circle into 8 equal parts. Similarly, divide that axis or one side of the rectangle into the 8 equal parts. To get the equal number of intersecting points, we should have the 8 number of circle division equal to the 8 number of parts into the axis or the one of the side of the rectangle. So that like this, you can get the 8 equal parts or 8 intersecting point of the curve. So then from the whatever you are going to get intersecting point, you can see if I show some annotation. So if you see this particular concept, this point, one point is moving with the one point, one is intersecting with one, then two is intersecting with the two. Then if I go ahead, three is going to intersect somewhere here. Then four is going to intersect here. Okay, like this on front side of the helix will be covering. Then if we go ahead, you can see the intersecting points, and we'll close this animation. So okay, so if you go ahead like this, we'll get the next part of the curve or next intersecting points of the curve. Like this, third, fourth, fifth, sixth, seventh point will get. And the front side of the curve I will show by using dark line, and another side that is which is not visible to my naked eyes, it will be by dotted line. You can see the I will join those P1, P2, P3 points up to the P8 point. One other side of this will be not visible to me. This is the front side of the curve. I have to draw with the thin curve, and then I will draw either side by the dotted line. So this is what the helix for one complete revolution of the curve. Very simple uh, concept. You can see watch again this video and you can draw. Next is helix on cone. So before that, we should have a concept of cone. Cone is a surface generated by moving straight line, keeping one one of its end fixed. That is, and other end is makes a closed curve. The fixed point, I can say vertex or apex, and closed curve is the base. If the base of closed curve is a circle, we get cone. You can see on the right hand side there is a picture of right circular cone with the base and apex. If you go ahead, the line joining to all the generators of the center of the base is called apex axis. Line joining the apex to the center of the base is axis, and its axis is perpendicular to the base. Then it will be a right circular cone. Right circular cone. If the axis is not perpendicular to the base, then it will be the oblique cone. Any other than as it is 90 degree, it will be a right circular cone. Apex with the base center. Now we'll see the one more problem based on the helix on cone. What I mentioned, draw a helix for one convolution upon the cone of base diameter. Cone base diameter is given 70 mm, and axis of that particular cone is given 90 mm and pitch is 90 mm. That means axis is equal to 90 mm. For one revolution, we have to draw this. Again, same revolution. If they say 1.5, 1 or 2 revolution, then 360 plus 180, that will be 1.5 convolution. 2 convolution means the 720 degree revolution. That means two times the helix will be wounding on the cone. So you can see I have drawn a circle first. I have drawn a circle first of 70 mm base diameter. Then I have drawn divided the circle. Then the front view, you know, the cone of right circular cone front view will be the triangle, which is based on the HP, that is horizontal plane, and then divide the circle equal number of parts into 8 equal parts, that is 45 degree or by the arc circle as we did in the practical. So again, divide the slant edge of the right circular cone again into the 8 equal parts. Join with this base. So all the projection you have to take vertically upward. So one with the one, two with the two, just like in the helix. So whatever number of intersecting points will intersect together, it will be the point of the curves. So this is the point P and P dash, or P and P is joining. 1 and 1 is joining together. 3 and 3, 2 and 2 is joining. 3 and 3 joining. 4 and 4 is, as you can see, 4 is on the circumference of the circle. Also, this 4 is of right circular cone. The 4 point is also meeting together. So it is front side of the curve. So and the 6, 7, 8 all are the another side of the curve. That is half part of the thread, or you can say the that particular curve. So if we join together, P1, P2 up to the P8, so it will be the, you can see, one side is of the straight line and one side is of, you can say, dotted line, because the other side, on that side, it will not be visible for me. This is the front view of the cone. If I go for the top view of the cone, I have to project all the points, which are points of the intersection, downward. That is up to 1, 2, 3, 4, 5, 6, like this. You have to take downward all these points, and wherever it is intersecting those points, you have to join the curve. So this is where you can get top view of the curve, top view of that helix. If you see from the top, it will be your helix on in the top view. So what I will do, what I did for, once again I will repeat. So here the one is joining with the one. Project these two on the one second point. Then similar way, project the third point and the third point. 2 and 2 is intersecting. Again, you can see similar way. It will be joining all the points with the French curve. It will be the helix on the curve. Well, you have to see where it is exact intersecting. This one point, you can say, I will say again, straight line. This one line is, if I go ahead, it is intersecting, C is intersecting, we have to take downward, C will be downward. So you can, or what you can, one is another method, this point to this point, 1 to center to 1, center to 2. All these points you have to mark on the corresponding. So this distance, these two, this distance, I have to take into the compass from center to this. I have to mark. Similar way, this distance to this distance I have to take into the compass 2 to 2 dash, and take the projection from the origin, mark the second point. Similar way, 3 to these 3 points. Take this distance in a compass from center to the third projection line. Mark back on the third projection. Like this, you will get the points of the curve, and all the points you need to join. Like this, we can cover the curve in the top. Very simple, but need to do the practice. Okay. So next we'll go ahead. So if you go ahead, there will be the curve like the, you have to draw by using the curves. You need to draw the actual by using actual practice in the system, or by using instruments. So you can see the actual diagram of the helix on the cone. This diagram shows the helix on the cone for multiple 1 revolution, 2 revolution, 3 revolution, and 4 revolution, and 5 revolution, like this. And this diagram is indicating actual diagram of the helix on the curve for the 1 revolution of the curve. So applications, various applications of the in actual case are there. Helical curve on the staircase, external internal thread, worm gear, shape of the springs, helical spring, compression spring, etc. etc. Helical groove cam for rotation. So these are the pictures available in the next slide. You can see these are the application: helical gear, compression spring, helical staircase, and these are the types of the string, tension string and all. Cam profile for the automation, threaded bolt and nuts, internal external threads, etc. We can manufacture by using the Helix Curve concept. So this is all what we can uh, say learn in the helical curve. So what is the helical curve on cylinder? What is the helical curve on cone we have seen in this particular section. Thank you.